Hey everyone, welcome back and welcome to the second part of the PongGDX tutorial series. So in this video, I hope to cover over a little bit of like the design approach to this project and something to keep in mind for most game projects you plan on building in the future. And I also want to get the basic settings of the application window set up along with just some of the understanding about some of these other modules that we'll be working with and the asset directory. So if you remember from the previous video, all we got set up was the application. It just kind of generated the main project, and in that it made all these files and folders and modules for us and ended up spitting out this main application file that's located in the core directory or the core module and in our main source directory. So from there, let's talk about how you should be approaching designing a game. So there's kind of a lot that goes into actually making a game. Now, I'm not just talking about programming it. Yeah, that part can get really complex really fast, but to even get to that part, you at least need to know what you're doing or what you're expecting to get out of that game. So a lot of places that I've read from a lot of like indie developers and whatnot have said really get the basic core game mechanic down first. Get a proof of concept going of the main idea of your game. In this context of Pong, that would be just like making sure you have some kind of ball on the screen that can bounce around a room, and you have paddles that it bounces off of, and you can score. So it doesn't matter how pretty it looks. It doesn't matter whether or not the game itself has menus or sounds or anything. Just make sure your game mechanic, the core, like the backbone of your fun element of your game, is something that's actually fun. And to test that, that's why you don't want to get too involved with the overhead parts of audio and graphics and menus. You don't want to get lost in that, because that'll make you lose the enjoyment of creating your game. And then there's no reason to create that proof of concept anymore, because you already lost faith in it by getting too bogged up in the menus. So for our approach, how we're kind of going to be doing this is a way that I think will really help you get into the game. So getting the backbone set up will involve making sure our application window runs, like getting something on the screen to start, and then we're going to be getting a paddle on screen, just a paddle that we can move. That'll be its own little video, tweaking and modifying it. Doesn't matter how short or long it goes, but we need that paddle to work as we expect it to work. And as long as it can move as we want it, then we can move towards making a ball that has the physics that we might expect the ball to have, and making sure it can bounce around the room and bounce off the paddles that we made. And then from there, we'll just have two paddles at that point, and just kind of see how that works and change things as we go up to that point. So we're going to get that structure of just that main idea of our game down first before we get too involved in the menus and get involved in like getting sounds, particle effects, any kind of fancy shader effects, or images or anything like that, because aesthetics don't matter if your game aesthetics don't really matter if your game doesn't function, if it doesn't work. So that's kind of how I want to approach this project with you guys, is you got to make sure that you have something that's fun for you and fun for other people. Now, I know this is just Pong, Pong isn't necessarily the funnest game on the market anymore. It's not a top seller. Everyone plays it. It's the next big thing. It's been out for a long time. And this project is more so just to really get your bearings with LibGDX. And even though it's a simple game, we are going to be touching on some very high-level intermediate topics, such as GLSL shader language, as someone had requested. And I realized that's a really good idea, because you can get that involved in any project, because it really adds a nice kind of spice to the game as far as like the aesthetics go. So that's why that's going to be kind of towards the end, but I will be making that specific tutorial series linked alongside this project. It won't really tie into this project until that comes along, of course, but I will be making that series alongside it as its own thing. And then we will have some like shaders specifically built for this game. So that series will be on its own, doing its own stuff, showing you guys how to do like grayscale, how to do like wobbly effects, how to do like warping effects, and doing like saturation or bloom, Gaussian blur, that photo manipulation type stuff. And understanding the GPU pipeline, OpenGL pipeline, as far as working with the GPU. And so we'll be seeing that stuff, and that's very high level. And then we'll also have like particle effects, and we'll also have some different kind of camera implementations that like with screen shake possibly, things like that. So those will be a little bit higher level than more intermediate than people normally see in some of these LibGDX videos, where you're just getting box 2D set up, or getting images on the screen and moving them around with the keypad. We're going to also try and include maybe a little bit of controller support, just because I want to take a look at that, and it probably won't be too involved for this particular project, but it will help me at least get started in that change that they recently made with LWJGL3, how it has better controller support now, being able to pick up and watch whether a controller has been connected or disconnected, which was always a headache in my time. But anyway, let's move on from that. We know that for this game, as far as the design goes, we're going to want to have something that manages the game itself, so running the actual interactive game logic of gameplay. And with that game manager, it's going to manage what's on screen at the time, so whether we're in a menu or playing the game. Then there's also going to be the audio manager, whether sounds are playing or not. There's going to be an asset manager, and in that asset manager, it's going to load all our assets up for us, and we're going to be able to ask it for assets that we want to render to the screen. So like certain textures or texture atlases that we have, we'll be able to request those from the asset manager. And then there's also going to be the input manager. That's going to handle all our I/O input from like the keyboard or the mouse or the controller, and we can generalize that, which will help us map keys and whatnot. And there's also going to be we have our main application class, and in the application class, it's going to delegate all that gameplay stuff and everything. You see how we're doing a batch, like we're drawing this image as we see for the default app. It's going to delegate all the drawing to the game manager, delegate all the audio sounds to the audio manager, delegate loading all our assets to the asset manager. We got to make sure that this top level really shows like, okay, we're playing a game, this is the order we have to do things, and that's all the application level cares about. So we'll start by getting the empty kind of classes set up for that, and then getting into those granular steps of like implementing game logic and drawing on screen in the next step. So just so you guys can understand the project setup we have right now, we have these 5 modules. There's the iOS, HTML, desktop, core, and Android. The one we're going to be paying the most attention to is the core module. That's just the way that LibGDX works. What it does to perform the multi-platform capabilities is it has all these modules that reference the core, and it compiles all your core game files to work on these other devices. So like in the Android one, there's in the source, go into this Android launcher, you'll notice it'll say new application. Keep in mind, application is just the general word I used, but if you go over here, you see this is the application class. That's what it is actually referencing. It does this initialize method that allows it to load up our game onto the Android device, and so it's kind of like a wrapper. So this is like an actual it does like actual Android. You'll see there's this Android method being called protected void on create bundle saved instance state. That is an Android specific Java method, and we load up an Android context, and that's what it works with. So that's how LibGDX allows itself to be able to work on all these other platforms, which is great. It's a very smart way of doing it. With that also, you'll notice in the Android folder we have the assets folder. Now, if you can remember from the previous video, in the configuration that we made, the desktop configuration, how I'm using the desktop launcher, the working directory, I have it set to that assets folder. Now, by setting the working directory there, that tells the desktop launcher that that's the root folder where all our assets will be. So like our images, our sound files, anything like that, the shaders, all of that is going to be located under the assets folder. And to give you an example, in the assets folder, I created an images folder, and I threw that badlogic.jpg in there. And so you'll see right here when I have this texture, which we will be getting rid of. We don't really want to use it here. But there's this image being loaded, and it calls this new texture class, and that texture takes an argument where all I have is images / badlogic.jpg. And that might seem weird because you might be thinking like, well, why isn't it under like Android, Android assets, or why isn't it under, like assets images? That's because the texture class is a LibGDX class that uses what is called like GDX files.internal, like absolute, and it gets like the absolute path using whatever the working directory is under. This same kind of being able to get this JPG is using the same thing as GDX files.internal. The internal method is looking under the root of the working directory. So when we set it to assets, that's where it's always going to be looking. It's just already in the assets folder, so we don't have to say assets images or anything. We can just say images and then anything under that folder path. And if you've done any kind of like file browsing, stuff like that, any kind of folder structure, you'll recognize that kind of form. But anyway, so then in this main application, it's just kind of drawing that image from the assets folder, and down in this render method, if you haven't really worked with LibGDX before, if you haven't seen my slides tutorial that I made back in, I believe, August or so, I kind of went over a lot of this stuff as like what's going on. LibGDX has this create method in the application adapter. This is kind of where you initialize all your managers and your settings, just anything about your app, the basic startup procedure here. You make sure everything's like initialized and set up the way it should be. And then in the render method, this is the method that's called every frame render. So pretty much it's going to be called hopefully 60 times per second. So you need to make sure this loop is like as efficient as possible. You have any like foul logic going on in here, or any kind of like naive approaches to anything, it will slow down your game. And so that's why you have to try and make sure you're thinking about like need to analyze the algorithms you have working in here, some of the logic you have working in here, and make sure it's really optimized and follows a clean, a really low footprint as far as like working logic in your game. So just to understand what's going on here real quick is this gdx.gl, these clear calls, what it's doing here is we're wiping the screen every frame. So that's good to do, because if you don't do that, then the GL context will keep everything that you rendered to the screen, like any images. So how we're drawing this image to the GL context we're working with, what's on in the application window, everything we draw gets put up. Let me show you guys real quick, get it started up real quick. So like how we have this image drawn here, if we don't clear the frame, the window, this image is like painted there, and if we moved the image, then it would just kind of smear, because it just paints it. It keeps everything that was left over from the previous frame render, and you don't want that. That's bad behavior. If you do want something like that, you should do it programmatically or with a shader. So just something to keep in mind, like you want to make sure you're buffering your GL context. So that's what that's for. You can think of that as like if you ever read up on double buffering for a canvas window in Java with like Swing or something. That's similar to the idea, where you're not using openGL. So let's close that real quick. And then you have the sprite batch. Sprite batch is something we're going to be using quite a bit. The sprite batch is used for doing batch culling of our sprites. And so like when we do want to render something to the screen, like draw an image to the screen, we have this batch, and every time you want to render something to the screen, you have to call batch.begin. So you're preparing this pool of resources that you're going to be using, and you're just preparing this like space. And when you want to draw image to the screen, you tell the batch where all those images are going to be and in what order they're going to be. The order that you tell the batch to draw them. So like if I have batch.draw, and then batch.draw like another image, let's say this was an image but another image, and I tell it to draw on the same position. If it's the same width and height, that means it will draw over this image because they're in the same location, and the draw order is set to where this one comes after this one. So we're saying like draw this one first and then draw this one second. So the order does matter here. So again, once you do that and have all your drawing, everything in place and everything's where it needs to be, the batch takes that all in, and then you do a batch.end. And when you're done, once you call that end, it ships it off in this nice pretty little package and does the shader work, the pass-through shader, to make sure everything's right, and sends it to the GPU, or I'm pretty sure it sends it to the GPU in that order, and everything that needs to be processed, or like it's in the GPU at that point, and the GPU will spit it out to the screen after rasterizing the image to the appropriate pixels that you have. So doing this batch.begin and batch.end is an expensive call. The reason I say this, and I'm saying it so early, is because this is one of those optimization things I was talking about. You need to recognize, like, oh, but this is just 3 lines. Whatever, nothing's really going on. That's just 3 lines of code. A lot of stuff is going on in the background. And understanding the API that you're working with, LibGDX, you need to know what these methods do. And hopefully I can tell you guys about that as I go along. Anytime we use something, I'll hopefully try to refer to any points that might be important to bring up. So, like, saying that this is expensive, that's important to keep in mind. You don't want to have, like, you don't want to do this multiple times. Like, calling this would just be terrible. And just saying batch.begin, batch.end. Okay, let's do another batch call. Render all these images one by one like this. Horrible efficiency going on right here. This would bog down the memory footprint that you're using so much on your GPU. So you would just want to erase that. Like, it doesn't hurt to do all your rendering in here. That's why you want to have this render method broken up into, like, do your gameplay logic, like move your paddles first and your ball first, move it where it needs to be, and then draw them to the screen. So, like, do all your logic outside of these batch calls before you start drawing to the screen. Do all your game logic, then render. Game logic, then render. Update, then render. So you'll see that once we start getting into the project. So with that, that's probably a little more than needed to be talked about, but just stuff to think about. Like, make sure you're looking at your code, like always doing those code hardening techniques. Like, really look at what you're using and understand what you're using. If you're just using a method, like, know what that method is doing and understand, like, what's going on behind the scenes. Learn about it. It only takes a quick, like, Google search to figure it out. Because the LibGDX library is freely available to everyone, and it's just right there for you to use. So with that, I'll kind of move on. This was just so I could get out of the app quickly. It's just like checking an input to see if I press the escape key. And using gdx.app.exit is the appropriate way to close your app. This is another thing I just want to note real quick. It does a effective teardown process, which is different than using system.exit. System.exit is considered a force exit, or force shutdown of your app. You don't want to do that. If you have gdx.app.exit available to you, please use that. That will appropriately, do the garbage collection and everything, kind of clean up your app as it stands, and then close down appropriately for each of the different type of platforms you're working on. So just keep that in mind. This calls the respective methods to the platform you're on. So yeah, let's get into looking at our desktop launcher. So as I mentioned before, we're going to be working in the core module pretty much the whole time. This is going to be like 100% until we start looking at, like, Android specific stuff, iOS specific stuff, WebGL specific stuff. So in order to minimize the amount of time we have to go digging through all these other folders, to really understand what I'm getting at, I want to make sure that, like, all I need open are my assets and my core. That's all I want open here, so I can navigate it really fast. I know where I'm at, and I don't have to dig too much. And even then, once we get all our assets built, I want to really effectively just have that Android tab closed, so I only have to look at this one project folder. So in order to do that, we have to set up a few public variables in our main application. As I mentioned before, in the configuration, it loads our application. So we do have access to this class here, and effectively what we want to do is just have a few public static variables that we're going to be working with. One being something, this is just something you've probably seen even from my slides tutorial, but I like to have all my game info, relevant info in my main application class, so I can reference it in the desktop launcher or Android launcher or iOS launcher, that kind of thing. So I get it all set up here. So I have my app title, and then I have my app version, and for all intents and purposes, we're just going to use 0.1 because we really aren't anywhere, and I don't really care to get as small as 0.01. And then I'm also going to have public static int app width, and that's going to be 720 for now, and then public static int app height equals we'll use 480. I believe that's even just the default that LibGDX uses, so that's good there. And then I'm also going to have public static int app FPS. So this is frames per second, and I'll show you what we're going to be using that for also once we get into it. So in our desktop launcher, if we go over here and we go to, you'll notice this config LWJGL application configuration class. It has some public variables for us that we're allowed to set, and so I have this title, and we're going to use the static context of our application class and grab our app title config dot let's do the width and height next. So we'll do application dot app width config dot height equals application dot app height. And then let's get into that background FPS equals application dot app FPS, and I'll explain what this is in just a second. And then there's also the foreground FPS equals application dot app FPS. Oh, new keyboard, kind of clacky and still getting used to it. So we'll close that off. So to understand what's going on, we are setting our LWJGL configuration to have the title of the app title in our application class here. If you don't understand a lot about object-oriented design, I'll give you a little tip here. There is the visibility of your variable. By default, if you don't explicitly state a visibility, it will implicitly assume that you're using private. So there's differences between like public, there's public, protect, if I can spell it, protected, and then there's also private package visibility or class visibility, data visibility keywords. So you'll notice they're all orange. That is because they're keywords. And so public pretty much allows you to see it anywhere outside of this class, no matter if you're inside a folder under, that's nested deeper than the this root level, or in the same folder, or even outside of this folder. So like here. But this is different. I'll explain that in a second. Protected only lets any class that's above this application or in the same folder as this application class. But anything that's in like a subfolder, so if I have like, let's create this managers folder since we're going to need it anyway. If I were to have like my assets class, which is going to be our assets manager, if I were to reference this or try to reference this batch and it was protected, I wouldn't be able to. It's outside of the scope, or it's like below the scope of the application class. And if it were private, that means nothing can see this sprite batch, for example. You can't use it anywhere outside. You would need what are called accessor or mutator methods, also known as getters and setters. So you'd have to have like a method that's like, you'd have to make a public or protected sprite batch get batch and then you return the batch, and then you can bring that sprite batch out of this class if it was private. So just some quick learning there for you guys on object-oriented design in Java for class visibility. And static just means like it's kind of like a singleton, so there's only one context of it. So if it's public static, that means you can just call a static version of our class. You don't need an instance of our class. So like if we had a application app equals new application. So if you had app, you'll notice that it's like static member is accessed via instance reference. You can do that, but you're always going to get the same instance across, like even if you had a bunch of these, so you had like app 1 and app 2, it's always going to return the same instance. So even if you modified those, you're only going to get the same one. It's static. It's just like whatever is in the scope of your project, that's the only one that's going to be used. So like if it wasn't static, then yeah, it's only going to be in the context of the app. Like if this was app 1 and you used like app title and you changed it in app 1, and you made another one called app 2, and you change that to something else, they're going to be different. They have their own copies. So just something to think about, just more about that OO design and private or package visibility. So when we do it like this, that means we're just getting the raw static reference there because it is public and we can access it. So now again, with this background FPS and foreground FPS, sorry for that spiel there, but it is important when working with Java to understand like what you're doing as far as like good package design and good object-oriented practices. These are the frames per second that your app will run in, your game, like how fast it's going to be calling this render method. So when you have this set to 60, it's going to be rendering 60 frames per second. It's going to be calling this render method 60 times per second. So that's just kind of a standard to use. The difference between background and foreground is that this is what it will, the background is the frames per second that your app will run in when it's in the background, and in the foreground, obviously that is when your app like is in focus or in the foreground. So you want those to be both the same because there's really no reason to have them different, especially if you're using, or unless you're using like a fixed time step, then there's really no reason to keep these different. So I always set them both to the same number, which is more often than not 60 frames per second, as that's what our eyes perceive as like the highest frames per second. It's the smoothest looking too. So with all of those set, you know what, I actually forgot to include our version number, so we're gonna put some space here, application.app version, and I'll add a V there. And so now that we have all these set up, let's kind of see what happened here. So now that I run it, we should get a window that is 720 pixels wide by 480 pixels high. And you'll notice now the window doesn't say application, but it says PongGDX. And so that's our app title with the V and the app version. And so everything worked out as expected, and the window is centered, and you can actually change where it starts, but we're just going to keep it centered because that's the most logical place to put the window when it first opens. So with that, I think that's all we're going to cover for today. That was a lot of object-oriented stuff to cover also, more so than I expected, but at least we kind of understand what's going on. We even made a managers folder. We looked at the asset folder and why these directories are set up the way they are and what they include. So with that, I hope to see you guys next time, and like, comment, subscribe as usual. I am of course gonna keep pumping these videos out now that I actually have a plan set up, and I actually already have a few of the videos recorded, so such as the GLSL shader tutorials that I was talking about. I have 1 or 2 of those already ready, but I'm gonna be giving myself a little bit of a buffer. So just keep in mind, I do have videos actually recorded for you guys now, and I hope you enjoy what's to come. Thanks for watching.